Elizabeth McGreevy is an executive director of Project Bedrock, a nonprofit organization that promotes using mountain cedars and other nature-based solutions to regenerate degraded limestone karst country in Texas. She's also the author of the book, Wanted, Mountain Cedars, Dead or Alive.
Okay, so we've had some of the previous speakers talk about more details of the different Ashe Juniper cover types and all that, but what I'm going to do here is to put them into two basic categories. And that's why my title is The Ecosystem Benefits of Ashe Juniper Pioneer Thickets and Old Growth Cover. And just an overview, I'm going to talk about the key differences between the two, regional preference, ecosystem benefits, and closing comments. Basic differences. Pioneering thickets, they're shorter, they're less diverse, they're typically in your less than 30 to 40 years old. Old growth cover is taller, more diverse, and in your 200 to 250 plus range. And there's a side-by-side comparison of the two, where, pioneering thickets represent early succession, while the old growth represents late ecological succession. Pioneering thicket indicates degraded soil. Old growth sustains healthy soils. Pioneering thickets were historically uncommon, while the old growth was very common. And in all the different, I spent, 25 years, just 5 years short of Lisa's, on doing research into the historical documents, and they were using the words timber, tall, stately. Even when they used the word thicket, it was integrated with the word timber, and timber trees are not bushes. So here's kind of a diagrammatic difference between the two. Your pioneering thicket is defined by bushes. And a bush just kind of starts about like so, and then just has branches coming out. There's no well-defined central trunk. The trees that you find in old growth cover, basically three different types of forms. You have your oak-like that has the trunk come out, it fans out like an oak tree. Excuse me. You also have your pine-like. There, the central trunk almost always goes all the way to the top. And then you have your multi-trunk. Pine-like, here's two examples, and one person asked before, are these eastern red cedars? About one in 100 will be an eastern red cedar just along the Balcones escarpment, but I find these all the way to Kerrville, Lakey, in areas like that. And also, if you look at their little leaves underneath a 200 times magnification, if the leaflet edges are serrated, meaning toothed, then that means it's not an East red cedar. East red cedars have smooth entire edges, so that's how I know. Oops, sorry, wait. The oak-like ones, the one on the left is in Bull Creek. The one on the right is in Mission Hill Park in New Braunfels. And those are both very, very large. The one on the left has a trunk of about 21 inches. The one on the right is about 26 inches. And then you have your multi-trunk. And then typically it almost could pass as a big shrub, bush, but it doesn't. You see how it still has that really well-defined central trunk. And sometimes it will have like a lower branches down lower. And then you have the juvenile trees. Now, this is a normal part of woodland forest regeneration. When they come in real dense like this, you can call them dog hair regrowth. Otherwise, they occur just scattered underneath the understory. A lot of people like to get the loppers, cut them off, thinking that they're the same thing as a pioneering thicket, but no, they are part of woodland regeneration. Aging junipers. When you can learn how to age your junipers, it helps you determine the age of the cover. Like I said before, the different range of years. But you can't really count the growth rings because they put on more than one growth ring a year. You can look at the fruits and pollen. If they're producing fruits and pollen, it means they're at least 10 to 20 years old. If they're not, then they're going to be younger than that. If you see the trunk lichen on the bark, which, what's it called? It's Cyanospora albicedra. If that is growing on the bark, the trunk, or like the very base of the bush ones, then they'll be 5 to 40 years old. After about 40 years, that goes away and the bark starts to shred. And so if you have shredding bark, it's at least 40 to 50 years old. The age can also be estimated by measuring the trunk width 4.5 feet from the ground, which is your DBH. You take the trunk DBH in inches and divide it by the growth rate. Now you want to have, since this is an estimate, you have a range. So you divide the growth rate is 0.1 and 0.06. So that you get a range of ages. The picture there on the right was taken at the Shield Ranch. And it has about 31.5 dBH. That makes it about 315 to 525 years old. Because this is growing in the upland area that probably would have been exposed to any periodic fires in the past, and it's a lot drier up there, I would lean more towards 500 years old for that tree. If it's growing, in the bottomland area with more moisture and all that, probably more like 300 years old. So where do these trees grow? You can find them in bottomland mixed forest. You can find them in bottomland and bluff cedar breaks. The true cedar breaks, a lot of the pioneering thicket that people see today, that's what we have so much of, those are not cedar breaks, those are cedar thickets. The true cedar breaks that were described in the past were always consisted of timber trees, were tall, had healthy, dark, rich soil. This is a little remnant cedar break in Mission Hill Park in New Braunfels. Hillside dryland forest. Now this is what's going to be up higher and cover the hills and the slopes. And this one I took near Canyon Lake. This is definitely old growth. It's got, all the lichens and debris and moss and healthy soil and a mountain lion den right behind me as I was taking this picture. And then you have also the prairie motte and woodland. Now look at the shape of that tree. At a glance, you may think that's a live oak. Live oaks do that where they grow their branches down. They do that in the middle of a grassland to prevent grasses from growing underneath them because we have short trees. So trees have learned to grow branches to the ground to keep the fire out. That one there has about a 33-inch trunk, making it at least 300 years old. Regional preference. They prefer regions with carbonate rock. That kind of aqua color in the middle shows approximate extent of carbonate rock in Texas. In Texas, most of this is limestone. And this type of region can be called karst country. Some may call it karst terrain, karst land, but I like to call it karst country. And it's limestone bedrock with very shallow soils. And it's characterized by rocky surface features, holy rock, and other types of neat features, and underlaid by sinkholes, caves, and aquifers. The upper karst variability affects water use. When Dr. Keith Owens came out with his water use in 1996, citing one juniper growing in full sun, he said, 33 gallons of water per day. In his abstract, if you read to the bottom and said just the first sentence, he then says, however, due to extreme variability, this can only be applied to that one juniper. Did the media go with that? No. So, so therefore, studies have found out because the karst is up and down, eroded, might have caves, all these things, you cannot look at single tree use. You have to look at entire stand water use. When you do that, turns out they use about the same as oaks. Karst country soils are extremely fragile, very fragile. Most are very shallow, and the underlying limestone means it takes 10 to 40 times longer for our soils to rebuild than soils elsewhere. And a lot of that has to do with many places there's no subsoil, so that as the limestone dissolves, it's not contributing, it just gets washed down. There's no subsoil to hold on to those minerals, and therefore it takes a lot longer to rebuild. And so when you focus on juniper removal, it exposes these soils and can push the land towards rocky desertification. Karst country is part of the carbon cycle. Now, this is kind of a newer discovery. For a long time, they didn't know where I think it was like 20% of the carbon was going as part of the global carbon cycle. They finally figured out, oh, it's karst country. It's cycling the carbon, and when it's degraded, it cannot cycle it. Vegetation, soil, and microbes are critical for sustaining healthy karst function. Old-growth forests helps to sink more carbon than healthy grasslands. That is what this peer review, not peer review, but just literature review of all these different karst country studies from around the world have found out that forests are better on top of karst country at sinking carbon. Now, of course, healthy vegetation is going to be better than degraded cover, meaning if you have a healthy grassland and a degraded area, the healthy grassland will sink more carbon than degraded, absolutely. And this is the real problem. Texas karst country has been repeatedly clear-cut, burned, and overgrazed since the mid-1800s. Much of it remains degraded today with less than 2% organic soil carbon. The native grasses have difficulty establishing a dense cover where it's degraded. Pioneering thickets can help rangeland grasses if given the time and the proper management. Okay, ecosystem benefits. The pioneering thicket is short-term regeneration. It's more like 10 to 75 years. Helps to regenerate forests and improve grassland conditions. It kind of like preps the land for grasslands to do better. Old growth cover, long-term sustainability, hundreds of years. It sustains biodiversity, groundwaters, mitigates erosion, flooding, and fire risk. And this was provided to me by Lisa, and it shows one of the studies that they did on the soil organic carbon. The open area, which is your kind of your degraded area, versus a young juniper area, and then your old growth juniper area. So there's a significant increase in the amount of carbon. Pioneering thicket, they may not be pretty, but they do spread fast and prolifically. They cover the ground, they improve storm flows, they help rebuild limestone soil, they act as a nursery for new plants, they increase karst porosity. Their dense canopies buffer the ground from hard rains, hot sun, and high winds. And that's really important in a region that gets flash floods. Pioneering thickets shed a large amount of slightly acidic organic matter year-round, and it's really tiny, so it kind of interlocks and produces a really nice duff. Now, the debris and canopies slow and seek heavy rains. And I've watched it. If you're really paying attention in these younger pioneering thickets, you'll see how, it looks like there's erosion going on. But when you look closer, you see these like little mini detritus berms that form on contour and are kind of duplicating the larger scale effect of the stair-step topography here. And over time, as it backs up, each time it backs up a little bit more. Over time, this organic matter builds up into a matted leaf litter that eventually becomes a nice loose and lofty litter as it becomes more old growth. Underneath this leaf litter, they enhance the growth of arbuscular mycorrhizal fungi. Now, that is kind of like your first tier of fungi, and live oaks cannot be pioneers because they need the ectomycorrhizal fungi really to get going, and they just can't start this by themselves. And the little fairy fingers on the left is an example of what it looks like. Arbuscular is more like fairy fingers, and it's not the regular mushrooms or your ectomycorrhizal fungi. They end up increasing soil infiltration and groundwater storage capacity. Pedro's going to be speaking, I don't know if he's here yet, is going to be speaking after lunch a little bit more about this. 3 times more rain infiltrates under karst country junipers than adjacent grass. Now, again, we're not talking about nice, healthy, dense stanza grass. We're talking about the typical kind of more sparse, like the ones in the picture. 20 times more groundwater moves through the limestone under junipers than underneath those same grasses. And they also enhance infiltration and what that does is increases aquifer recharge. For a long time, it was believed that only about 5% of the rain infiltrating into the ground was recharging aquifers. Then they learned, oh no, actually it's like 28 to 30%. And that means it is so much more important to do everything possible to infiltrate, because when you infiltrate, not only are you recharging the aquifer, but you're also decreasing downslope flooding and erosion. Why is it when people clear that sometimes they get more spring flows? Well, because of the good infiltration. After you clear the junipers, that good infiltration remains. And the springs increase because it's a parking lot. You know, there's no more vegetation there. And this happens around the world with all vegetation removal. It has nothing to do with junipers. It has to do with the fact that you just took out the vegetation. After 3 to 5 years, the infiltration degrades, other vegetation might start growing, and the springs decrease. Pioneering thickets also act as a nursery for new native plants. I mean, look at that. Everyone always bemoans, oh, there's no understory underneath the junipers. I'm like, well, stop pruning them up. If you prune them up, the deer can eat it. And here you got, it's like red oaks. Look at that. It's all Texas red oak. And everyone always says, oh, it's deer candy. I'm like, then stop pruning up the junipers. Old growth cover. Okay, this is what they can do. They maintain healthy soils. They manage storm flows. They support wildlife diversity. They sustain year-round gravity spring flows. They reduce wildfire risk and sustain the carbon cycle. And look at this picture here. Now that's a hilltop old growth, which I estimate to be at least 500 years old. And that is just, it's got debris everywhere. It's got mossy and all kinds of stuff on top of a hillside. And it's damp up there. The old growth will increase layers of debris, mosses, lichens over time. And they enhance and protect soil development and soil biology diversity. Old growth protects the rain infiltration to sink more overland flows and reduce erosion and the downslope flooding. And as you're just speaking about, it supports more than warblers. Historically, we have passenger pigeons, black bears, and jaguars just everywhere. Old growth, okay, now this is really important. Last summer, remember how hot it was? And I know that a lot of ranches out there were talking about how all their springs had stopped flowing, but guess which springs did not stop flowing? Those that were covered by juniper and or juniper oak forest. And the one on the left there, the smaller picture, that's just like that's like a 40-year-old little juniper woodland kind of thing going on. It's close to the top of a hill, and it only gets about 500 gallons of water per day, but never goes dry. It always, even through 2011, it was still flowing. And then the one on the right there is on a hillside in Lakey, and it was estimated in spring, not in summer, but in spring, about 10,000 gallons of water per day. And it flowed all through last summer. Old growth also creates a system that historically helped to reduce the spread of fire from grasslands into the forest. Someone asked, about fire. Fires back then they were not frequent fires. They might have been periodic, like every 20, 30, 50, 100 years. But the thing is they would have had to gone through some periods of time where there would have been no fire for a forest to get established. Once established, forests will literally create a morphology that protects it from the fire. And they'll usually be like a more closed canopy. They'll have certain species growing along the edge that are more fire resistant, like the Texas red oak is more fire resistant, creating kind of this wind current that will go over it. When you go in, you open it up and you thin it out, you get the dry wind blowing underneath the canopy, which not only dries out, removes the microclimate, more humid microclimate, but also will dry the fire underneath. That works for your forests where we have taller trees and all that, but not here in the hill country, because most of our trees are short. So when the grasses are growing underneath these short trees and then the fire's burning underneath them, it's going to most often torch out those trees. And I've watched that firsthand. And it's better to keep the grass from growing underneath. Now, if you have a larger forest, then you have grassy glades in the context, within the forest, then that's okay because they're kind of protected by the ring of forest around them. Concluding comments. Junipers on karst country are not the enemy. They are part of the solution. They are not invasive, since they are native and they're helping ecosystems. The word invasive means causing harm, and I hope I proved in my little short thing today that they are beneficial, not harmful. Knowing how to read your land makes more informed land management decisions. Learning juniper cover types and karst country basics improves your read. We need to learn to work with or mimic pioneer thickets to help move this land away from rocky desertification. Just in those pictures, two little examples is installing bioswales on contour. Remember the little mini detritus berms I was talking about? The same thing, a little bit larger scale. So that one there was constructed to go through a really, really degraded area of pioneering thicket, and now look at it, it's lush and gorgeous. Also, using things like boar goats, to help do fire breaks and shaded fuel breaks, integrating that thing. I know there's a big push to get the fire going out there first, but I think we should use solutions like this and then maybe bring in a little bit of fire here and there. But I believe wholeheartedly that it was the megafauna, it was the animals that helped sustain these ecosystems a lot more than the fire, that the fire might come in every 20, 30, 50, 100 years, but definitely not every 3 to 12 years. There's zero evidence that it was ever that common. So brush management should be a potential strategy and not the inevitable overall plan. Like whenever you're saying, okay, what should we do? The first thing that someone comes out and says is, oh, you need to clear out your cedars. No. That, is the word brush management should just be integrated as part of a holistic plan. Because we have a soil, not a cedar problem. Got questions? So I'm with, I kind of represent Project Bedrock, a new nonprofit. And if y'all don't have time for questions here, that's the link to the website. There's the written out website, so y'all can send me your emails with any additional questions and pictures. Okay. Hope y'all can do it.
Questions? We have time for a few. In the back. Go, if you call it out.
My question is, are you calling all of the limestone country karst, or are you specifically talking just about the karst limestone area?
The entire area.
So you're calling the Glen Rose Formation a karst limestone?
Yeah. It's all based on carbonate rock. But as we know, there's a lot of different types. So I'm just using it as a general catch-all phrase.
Another question? We have time for another one? Oh, go ahead.
Listen. You had a photo of an old standard juniper high up in the landscape. Is that tied to karst? Those kinds of sites, are they tied to more karstic environments?
Yeah, everything I showed a picture of is tied to karst. Yeah, absolutely. It's like if you take a cross-section of the whole area, it's all underlaid by limestone. If you need a rock bar to dig somewhere, you're on top of karst country.
Good deal. Hey, well, another question over here, and could you repeat the question so everybody can get it on the video?
Okay, yes, sorry. So in the back, he was wondering if I was referring to Glen Rose, karst, limestone and all that, and I was saying that karst country is just kind of like a blanket term for the whole region. And you were asking if the picture I showed up on top of the hill of a dryland forest is also karst. Yes, the whole area is karst country.
Good deal.
Anywhere you dig down, if you went on top of that hill and you dug down 12 inches or 2 inches, you would hit limestone. You're on top of karst country.
Take another question, if you'll repeat it. Go ahead.
sense of what causes the different forms of the, we talked about the pine, the oak form, and
closed.
Repeat the question. Sum it
I
up.
know the answer, but can I say it?
Repeat the question for.
The question is why do you get so many forms of the juniper? Why do you get like the pine-like, you know, why do you get the bush? Why do you get the pioneering? And, well, okay, because new evidence shows that we do have Junipers ashei, but we also have Junipers ovata. And ovata is a more ancestral juniper that, like the pictures I showed from Mission Hill Park, those are ovata, and that the two do hybridize. But it's still new research, and we still need a lot more. There are, of course, other theories that it's just simply growing conditions.
Other questions?
Yeah, I think we all should, because you know, it could really, if this is what it is, it could affect our management and how we make our decisions. You know. Oh, the reason it's called ovata is because when you look at the whipleaf glands under a microscope, you'll see that the gland shape is an oval. So it's ovata, O-V-A-T-A. I call it Adams juniper. Old timers call it lemon cedar because the sapwood has a slightly more yellow color. Absolutely. I think that a lot of the limb up is coming from the loblolly forest, the spruce, the fir, the redwood, all these places that have incredibly fire-adapted forests, and part of that adaptation is that they're really tall trees. And so you don't have to worry about that because the fire just burns right underneath. And I think that our forests have evolved to a drier situation and are shorter, and therefore they've learned to kind of like grow their limbs downwards to prevent, because grass is the most flammable thing that we have. Anyone heard about like the Hawaii fire? I mean, that was grass. It's like grasses are where the fires start, and you want to do everything possible to not let that burn underneath a short canopy forest. Yes? Yeah, okay, she asked, so what about junipers being explosive and all that? That applies to if you have a pile of dead junipers, it's explosive. But that kind of applies to any dead thing. They're actually moderately flammable. Now, a Kerr wildlife management study discovered that if they are maintained at 60% hydration in their leaves, that they don't really burn. If they're more than 70%, they don't burn at all. So the focus should be, that's what I say, is on the soil. If you get the soil better and you keep it more humid and hydrated around the trees, they're going to have less of a fire risk. Yeah, just send me a question, and I'll get that all to you. On the Project Bedrock, is still pretty new, and that's one of the things I'm going to start working on is developing a full reference list. But also my book, at the back of my book, I have quite a few. I have 25 pages of references, 9-point font.